Hello everyone. In this video we will learn about orthogonal matrix and the applications of matrices. That is, some problems on the matrix we will solve and also some word problem we will take on matrices. First we learn about the orthogonal matrix. What is an orthogonal matrix? See, any of the square matrix, if its transpose and the matrix, the product of them is equal to a unit matrix, then we say it is orthogonal matrix. So we can define it like, if A is a square matrix such that A dash into A is equal to I, then A is an orthogonal matrix. For example, suppose we have a matrix A and that is cos theta, sin theta, minus sin theta and cos theta. Then we know that A dash, the transpose of it will be cos theta, sin theta, minus sin theta and cos theta. Transpose is obtained by interchanging the rows and columns. If we find the product of A dash and A, that here is cos theta minus sin theta, cos theta into cos theta, sin theta, minus sin theta and cos theta. Then we know how to multiply. We multiply the rows to columns. So when we multiply the first row, it is cos theta into cos theta, cos square theta, minus sin theta into minus sin theta, plus sin square theta. When we multiply the second column, this is cos theta into sin theta, minus cos theta into sin theta. Second row to the first column, sin theta into cos theta, plus cos theta into minus sin theta, that is minus sin theta into cos theta. Second column, sin theta into sin theta is sin square theta, plus cos theta into cos theta is cos square theta. We know cos square theta plus sin square theta is 1. This cancels this, so it is 0. This term also cancels this, so this is 0. And this is also 1, so this is your unit matrix I. It means what? It means we can say A is an orthogonal matrix. Now we discuss some of the problems based on matrices, and the first one of them is find matrix B such that B into matrix this is equal to this matrix. For finding the solution of such problem, what we do, we consider the given matrix as A. A is given here as 1 minus 2, 1, 4. Then we consider the matrix B, that of the same order, 2 into 2, because the result is also here 2 into 2. So we take matrix B as A, B, C, D, that is of order 2 into 2. Now we have been given that B into A is equal to 6, 0, 0, 6. We substitute the values. B, that is A, B, C, D, into A, that is 1 minus 2, 1, 4, is equal to 6, 0, 0, 6. We know how to multiply. When we multiply this, we are getting A into 1 is A plus B. A into minus 2 is minus 2A plus 4B. C into 1 is C plus D into 1 is D, and this is minus 2C plus 4D equal to 6, 0, 0, 6. We know if the matrices are equal, then their corresponding elements are to be equal. It means we are getting here A plus B equal to 6. This is first equation. Then minus 2A plus 4B equal to 0. This is second equation. And if we solve these problems, then either we substitute the value of B from here by using the substitution method. Then we find from this B is equal to 6 minus A. If we substitute that in 2, we are getting minus 2A plus 4 into 6 minus A equal to 0. It means we are getting minus 2A plus 24 minus 4A equal to 0, which gives us 6A is equal to 24. It means A is equal to 4. And putting this value of A as 4, we are getting B is equal to 6 minus 4, that is 2. Now when we compare the third and fourth elements of this, we are getting C plus D is equal to 0. This is your third equation. And minus 2C plus 4D is equal to 6. This is your fourth equation. Solving these two, again we can get the values the same way. What are those? Let's see here. By solving these two, we are getting C is equal to minus 1 and D is equal to 1. And therefore, we are getting B as A, B, C, D. And that is A is 4, B is 2, C is minus 1 and D is 1. This is the answer. Like this, we can find out the matrix for such problem. Next problem we are discussing based on the symmetric matrix, and that is, if B is a square matrix and A is a square matrix of the same order, prove that B dash AB is symmetric if A is a symmetric matrix. To prove this, what we do? We have to use the concept that the symmetric matrix is the one whose transpose is equal to itself. A is symmetric matrix. It means A dash is to be equal to A. So we can write, since A is symmetric matrix, this implies that A dash is equal to A. We have to prove that this is symmetric. So we consider it as P. Let P be B dash into A into B. Now if we can show that P dash is equal to P, then we can say that this is symmetric matrix. So we go for P dash. P dash is B dash into A into B whole dash. We consider this A into B as one of the matrix, and this is the second one. So can we write this as A into B dash into B dash dash, since we know that A into B dash is equal to B dash into A dash. Now we can write this A into B dash using this as B dash into A dash, and this we can write as B dash dash as B, because we know that the transpose of a matrix is the matrix itself. Now we know that A dash is equal to A. So can we use that here? If we use, this will be B dash into A into B. And we can write the reason, since A dash is equal to A. And this is what? P. So we have proved that P dash is equal to P, which implies that P, that is equal to B dash into A into B, is symmetric matrix. The next problem is based on the matrix polynomial, or we can say power of a matrix. This is, if A is having the elements 1 0 minus 1 7, this is of order 2 into 2, then find K if A square is equal to 8 into A plus K into I2. For the solution of such problem, we write A here, that is 1 0 minus 1 7, and first we find A square. We know A square is equal to A into A, it means that will be 1 0 minus 1 7 into 1 0 minus 1 7. We know how to multiply. If we multiply them row to column, this will be 1 into 1 1 plus 0 into minus 1 is 0. This is 1 into 0 0 and 0 into 7 0. This minus 1 into 1 minus 1 plus 7 into minus 1 minus 7. This is minus 1 into 0 0 and this is 7 into 7 49. So we are getting this as 1 0 minus 8 49. Now we know what is I2. That is the unit matrix of order 2 into 2. That is 1 0 0 1. And we have been given that a square is equal to 8 into a plus k into I2. We substitute the values here. That is a square means 1 0 minus 8 49 equal to 8 into a, that is 1 0 minus 1 7 plus k into I2, k into 1 0 0 1. When we simplify, this comes as 8 0 minus 8 56, because we know this is scalar multiplication, so we multiply 8 to each and every element of this matrix A. Now we have here k into this. So k will be multiplied to each and every element, and that comes as k 0 0 k. We know how to add the matrices. The corresponding elements are to be added, so that becomes 8 plus k 0 minus 8, and this is 56 plus k. And we know that equal matrices means the corresponding elements are to be equal. So we find here the first element, that is a11 is equal to a11, 1 is equal to 8 plus k, which gives us k is equal to 1 minus 8, that is minus 7. But we have to check it for another elements also. Is it 0? Yes. Is it minus 8? Yes. From this also we can find this will give us 49 is equal to 56 plus k. And from this also we are finding k is equal to 49 minus 56, that is minus 7. It means k is to be minus 7 for this particular polynomial which is given to us. And hence we can write therefore k is equal to minus 7. The next problem is a word problem, which is a trust fund has rupees 30,000 that must be invested in two different types of bonds. The first bond pays 5% interest per annum and the second pays 7% per annum. Using matrix, determine how this must be invested to get a total annual interest of rupees 2,000. In such word problem, we have to construct the matrix also ourselves. So what we have been given here, the total fund is rupees 30,000. So we say total money to be invested is rupees 30,000. And we consider rupees X to be invested in the first bond and the remaining in the second bond. So we can write, let rupees X be invested in first bond. Then the money invested in second bond is equal to rupees 30,000 minus X or not. Now we have been given the rate of interest for the first bond, that is R1 is equal to 5%, and the rate of interest on the second is R2, that is equal to 7%. We know the formula for the simple interest, that is P into R into T upon 100. Here we have been given T is equal to 1 year. It means this will be P into R upon 100 or not. So we have to construct the matrices in such a way that the multiplication is possible in that. And we know that when we multiply any of the two matrices, the row is to be multiplied to column. So first matrix, that will be for the principal, we will make in terms of rows, and the second one, that is for the rate of interest, we will form in column. So we write, let A be the matrix, that is rupees X and rupees 30,000 minus X, and we write here this is for first bond and this is for the second bond. Same way we can write B is the another matrix, that will be a column matrix. R1, that is 5, we can write this as 5 upon 100, and the second one, that is 7 upon 100. This is first bond, this is second bond. Like this, when we construct the matrices, then it's very easy to find out the total interest. We can write total interest will be equal to A into B, and we multiply, that is X 30,000 minus X into 5 upon 100 and 7 upon 100. And when we multiply row to column, we are getting here 5x upon 100 plus 30,000 minus x upon 100 into 7. This is the total interest we are getting at the end of the year. According to problem, this is to be equal to 2000. So we find 5x upon 100 plus 30,000 minus x into 7 upon 100 is equal to 2000. Solving this equation, we find the value of x as 5,000. It means the money to be invested in the first bond is rupees 5,000, and the second bond it will be 30,000 minus 5,000, that is rupees 25,000. So we can write the answer. Therefore, money to invest in first bond is equal to rupees 5,000. In second bond is equal to rupees 25,000. In the next video series, we will learn about the determinants. Thanks for watching my video. If you have any comments or doubts, leave them in the comment box and I will get back to you.